Okay, we're solving what we call systems of equations by graphing. Okay, so we need to define what that word system is. A system is two or more linear equations with the same variables. So a system is two or more linear equations with the same variables. Okay, so you think of the term solar system, that's talking about everything in our around the sun, basically. Yeah, in our solar system. And yeah, we're talking about the planets, their moons, the different types of fields around there. All that put together is called our solar system. It's one thing, a system, but many parts. So our system here in math is two or more equations that are linear, and they have the same variables. We're just dealing with two today. Okay, we're just going to have two in our system. So it does get complicated with three or more, but we're not doing that today. All right, our first problem I want to get is write these two equations down, and they're part of a system. That means they're part of a group. So y equals x minus 1, and y equals 3 minus x. So two equations are different. And we're going to do something that we've done in the past. Okay? So I have two equations, and the first thing I want to do is I want to get a table going. And you're not going to do this. You're doing one problem with the table, thankfully, because these do take a long time. Do two columns and get 5 rows. And you got your x and your y columns. And we're going to do it for the first equation. So y equals x minus 1. Okay, I'm going to give you some x values, and you have to find me the y values. So let me give you the first x value. If x equals -4, what does y equal? So you substitute -4 for x. What's -4 minus 1? -5. If I give you x equals -2, what does y equal? -3. If I give you x equals 0, what does y equal? -1. If I give you x equals 2, what does y equal? 1. And if I give you x equals 4, what does y equal? 3. Okay? Do you guys get how I get all those numbers? I gave you these numbers, x's. I gave you all the x's, and you could come up with the y's. So I hope you guys can do that. And I will give you x's, so you don't have to think of those today. All right, so I got my ordered pairs. And great, we got some ordered pairs there. We're going to do it again, one more time for this one. I know, it's tough. 1, 2, 3, 4, 5, x and y. And I'll give you some values here. Okay, we're going to use the second equation. So we're not doing the first one anymore. We're going to use that second equation. And here, I'm going to give you the x values. You come up with the y's. I'm going to let you do it on your own. -4, -2, 0, 2, and 4. Figure out what my y value should be. And I'll give you some time to do that. So you put in those x values in for, these values in for x. Then that gives you y when you simplify. Be careful. Subtraction and addition are not perfectly the same. Okay, some of you seem to get it. Sophie, when you put -4 for x, what's 3 minus -4? 7, because it's 3 plus 4. So it's 7. Hudson, when you put in -2, what do you get for y? +5. +5 or +5. Good. Sam, when you put 0 in for x, what do you get?
Just 3.
3, just 3. Brad, when you put in 2 for x, what do you get? 1. And then Josiah, when you put in 4 for x, what do you get? -1. All right, so you should have gotten these values. Hopefully you got them all. Any questions on how to do that? It's pretty straightforward, and we've done it before. Okay, do you notice that they both have the same x values, -4, -2, 0, 2, 4? Do you guys see that? But there's something else that they have in common, and it's an ordered pair. You may look at the chart, see which ordered pair is common to both tables. Alex?
2 and 1.
Is this an ordered pair right here? 2, 1? Mm-hmm. Is this an ordered pair right here? 2, 1? Yep, that's another one. They both share it in common. And I want you to write that down. 2, 1. So important. You're like, why is it important? Well, they're common. That's why it's important. And I want to see if you guys understand. How many values could we have picked for x? Infinite. I could have picked fractions, decimals, bigger, smaller numbers. And I would have gotten y values. I could have done the same thing here. How many ordered pairs would they share in common? In common. 1. There's only one they share in common, and it's right here. That's the only one they share in common. You're like, fine. All right, that's what we're going to do. This is not the whole lesson. This is the lesson. Give me the two equations again, Darius. Y equals
x minus 1, and then y equals 3 minus x.
All right, these are two equations. Now, what I want you to do is I want you to get your graph paper, and I want you to fold it into fourths. So you're going to fold it hot dog or hamburger, and then fold it the other way after. So I'm going to do hot dog first, and then I'm going to do hamburger. You just want fourths. So when you get your paper, you should have this, fourths. Okay, and I want you to draw this first problem on the top left, So you're going to give me a coordinate plane, 5 by 5, 5 in each direction. So here on the top left, a 5 by 5. Go ahead and start that up. I'll do it here on my board, and then we'll do the same thing together.
Is this in one of the boxes?
Just in one, the top left box. Draw your coordinate plane. Okay, your first step on this problem, okay, this is kind of separate from the last one we just did, is to get these equations into our most preferred form. Now, up here, I didn't make this for this lesson, like I didn't draw this out for you guys this morning, but I did do it for those taking the quiz. What forms did you need to know for that quiz a couple days ago? A few days ago, I should say. Standard, slope-intercept, point slope. Which one do we prefer? Slope-intercept. Yep. You know why we prefer slope-intercept? Because it gives us the slope and the Y-intercept. I like that form. Okay, so are both of these in slope-intercept form? Is this in y equals mx plus b form? Yes, this one's good. Is this one in y equals mx plus b? Is that the y equals mx plus b form? No. Can anyone rewrite this so that it is in slope-intercept, Andrew?
Y equals -x+.
Good. Yes. So I just rearranged these two terms because of the commutative property of addition, and that's what I should get. Okay. You get them in slope-intercept form. That's good. All right. The first equation, this one up here, this is review. I want you to identify the slope and the y-intercept. Identify the slope and the y-intercept. And does that sound familiar to any of you? Identify the slope and the y-intercept. You saw it on your quiz. Like I put that in the instructions, identify the slope and y-intercept. Okay, Matthew, what's the slope?
1.
It's just 1. It's a number being multiplied by x. So here's a 1. What's your y-intercept? Jack? -1. It's the constant, the one without a variable next to it. Okay, you guys get those? You got to find those. Once you get that, you can graph the whole thing. All right, where do I start my graph? I start at the y-intercept. Why do we call it the y-intercept? It's where my line hits the y-axis. And so where does it hit it? -1. So you put a little point right here. That's 0, -1. That's your first point for the first line. And then I also have my slope, which is what? 1. So what's the rise over run represented here? Up 1, over 1. So you go up 1, over 1 to the right. Up 1, over 1 to the right. But what if I didn't know I could go to the right? Maybe I went to the left. Could I go to the left? Can I put some points off to the left? Yes. But how would I do that? I'd go down 1, over to the left 1. And they still line up in that fashion. So go ahead and connect them. That's my first line. Okay, so you have to be able to do that. If you could do one line, hopefully you could do the other line. And when you graph both those lines, something special happens. Well, I hope something special happens. That's the goal. Okay, how many of you got that first line, how to graph it? Like you're like, okay, not too bad. Find those parts, put them on. Do it for the second one. And for help, Jackson, do you happen to know what the slope is on the second line? -1. Very good. And then William, do you know what the y-intercept is on that second line? On this second line right here? What's the y-intercept? Yeah, it's that +3. So it's that 3 value. It's the constant, the one without a variable next to it. All right, go ahead and put those on the graph. So where do you start, Sam?
The y-axis.
Yeah, on the y-axis, where?
Just go up 3.
3, yep. That number 3 is my starting point. 1, 2, 3. That's my first point. And then from there, where do I go, Drew? Using my slope.
Down 1. Over 1.
To the right. I can go down 1, over 1 to the right. Down 1, over to the right. Where else could I go? Not down 1 to the right. I can go up 1, 1 to the left. Okay, so I'll do that from here. And they should form a line when I connect them together, if I did it right. You guys notice anything about those two lines? Yes, sir? They are perpendicular. Yep, that's cool. I'm glad you picked that up. We're going to see another thing with those slopes, but there's something else about them. Don't they cross over once? Where do they cross over? See that point? What's that point? Say it. 2, 1. Looks familiar. Do you guys remember where that was from? That's the ordered pair that they share in common. And you're like, Mr. A, I didn't believe when you said that's the only one in the whole ordered coordinate plane that would fit. Do you guys see, is there any other point where these two lines will cross? Any other point? It's only at this point right here. This right here is my solution. That is finding the solution of a system of linear equations by graphing. That's what you're doing. That's today's lesson. Get that point by graphing. And we found it here. Hopefully you didn't need enough. How many of you have that point on your graph? Can you label it that, 2, 1, so you know what we're looking for? Because that's the answer. All that work to find that one point. Okay, I need to review this because I need you to understand exactly how significant this is. Ready? Mary, how many points are on this line right here? How many points, technically? Sorry?
4.
Okay, 4, 1, 2, 3, 4. But how many technically?
1 or 2.
More. Keep going up. Throw out a number. 5, go up. This is cool. Should I make her go all the way up to the very end? No. It's how many, Mary? Infinite number of points. You know, there are points right here. All those points. I'm talking all the points. So how many points are here on this line, everyone? Infinite. How many points are on that second line? Infinite. How many points do they share in common? 1. There's 1 point right there, and that's your solution. Okay, but I'm still not sure I don't think that's that special. Does anyone remember what's the x value here? 2. What's your y value?
1.
Okay. It should fit into both of these at the same time. What's x? 2. What's 2 minus 1? 1. Does that fit? Yes, it does fit. What about this one? What's x equal? 2. What's 3 minus 2?
1.
1. So it fits both of them. You know how many other points do both fit in both of them?
0.
No other points. That's it. That's my solution. Okay, that's great. Let's do another problem. Let's get a little bit tougher, actually. Let's go with 4x plus 2y equals -8. And then 2x plus y equals 2. 2x plus y equals 2. Sorry, so making you follow me. Okay.
Is this on the graph paper?
Do this on your notes paper. Yeah, good. And then when you get your graphs, you put that on the graph paper. So the first thing I need to do here, guys, is I need to get these equations in a certain form. What form is that, Hagen? Slope-intercept form. That's the easiest way to graph a line, slope-intercept form. Okay, is the first one in slope-intercept form? No. Does anyone remember how to do that? Solve for y. Get y by itself. And I need some help because I'm stuck. Sophie, if I'm trying to get y by itself, what do I do first to this equation?
Subtract 4x.
Subtract 4x from both sides. Subtract 4x, good. And I'm left with 2y equals, how do I want to write this so that it's getting closer to slope-intercept form? Like, should I do -8 minus 4x? Or should I do -4x minus 8? And that's getting me closer to that slope-intercept form, but is it there yet, Brad?
Yeah.
It's so close, but there's something in front of the y. Yeah, so what do I do to get it by itself? Everything gets divided by 2. I'm left with y equals, what's this right here, Hudson?
-2
Good, and then that?
-1.
All right, great. We got the slope-intercept form of that first line. Okay, William, the second line. I want to get in slope-intercept form.
Subtract 2x from both sides.
Oh, nice. All right. And then somebody else tell me how I write that out. Y equals, Eva, y equals, how do I write it?
-2x plus 3.
Great. All right, I want you to graph those on a coordinate plane. You just use the top left. I want you to use the top right quadrant now. So use that top right. Go 5 by 5 every direction. And graph those two lines on your paper. I wanted to say, it was funny, I was going to encourage the other class, and I'm going to encourage you. But once I was ready to encourage them, I got interrupted with a few questions, and I totally forgot to give them the encouragement. Here's my encouragement. If you guys know how to write these down the right way, wow, they're really focused. No, it's good. If you're focused, you can do it. I'll wait. I'll wait for the encouragement. But you guys are showing good signs of things I haven't seen in years past with 7th graders. And I'm thinking, wow, that's really going to help them later on. So it's good. I see good things. Anna Grace, can you give me those two equations again that we found in slope-intercept form? Y equals?
Y equals -2x minus 4 and y equals -2x plus 2.
Okay, thank you. All right, go ahead and graph it. And if you're lost, I'll try to help you out. But hopefully you're getting some things on your own. All right, Philip, I'm stuck on the first equation. I don't know. I don't even know what the slope or the y-intercept are. What are they? Oh yeah. Gotcha. Now I remember. Gracie, I just totally forgot what Philip said. So I need for the second equation what the slope and the y-intercept is.
The slope would be -2.
Oh.
And like the y-intercept would be +2.
Oh, okay, nice. Got it. That was easy. Okay, I need someone to help me to graph the first line, and I'm picking Henry. Where do I start for the first line?
You would go down -4.
1, 2, 3, 4. Oh, yeah, that's your y-intercept. Great. Where do I go from there?
You would go down to
1. 2.
and then over 1.
Oh, okay, yep. Do you notice I made you go 5 by 5, and you're like, wait, Mr. A, you need to tell us 6. Well, do you notice that I had to create another line there? But I didn't have to make that point right here. Instead of going down 2 over 1, what else could I have done to get a point on that other side? You can go up 2 over 1 to the left. Why does it have to be left and not right? Because that's still up to, I'll make this better. That's still up 2 over 1. What's the slope of this line? -2. What do negative slopes tend to do or always do? They go left to right, they go down. And this one's going to go down from left to right, so I need to do that. Up 2 over 1, up 2 over 1. All right, I'm going to connect my line. I connect my line. Oh, perfect. Connect my line. Okay. Hagen, I need help on my second line. Where do I start?
You go up 2.
So I'm going to start right there. Great. Where do I go from there?
Go down 2 and then over to the right one.
Gotcha. And then I need another point.
Go down 2 and then over to the right.
Mr. A just said something about going up and then the other. How do I do that? I don't want to go down anymore.
You can go up 2 and then over to the left.
Oh yeah, because the same line. Bless you. Bigger dots cover a lot of problems. Okay. What do you notice about these two lines? And you guys said something about this earlier with perpendicular. They're not perpendicular, but they are parallel. Are these lines ever going to cross one another? If they're technically parallel? No. And how did you know that they were parallel before you graphed them? They both have the same slope. Now, you still have to graph them, but you should get parallel lines. Do they have the same y-intercept, though? No, they have two different y-intercepts, but they do have the same slope. Okay, how many times are they going to cross one another? 0 times. But how many answers are there for this line? Infinite. How many answers for this line? Infinite. You know how many they have in common? No solution. There is no answer to this system of linear equations because they'll never cross. They'll never share an ordered pair. Never. Ever. Yes, sir. Go.
On homework, if we just notice that the slopes are the same, can we just not draw a graph?
No, because I want you to get practice drawing a graph. So if you know they should be parallel, guess what your graph should be? Parallel. Like if you get them perpendicular after you said they were parallel, you did something wrong in your graphing, which is what I want you to get practice with. So thank you for asking. I know. Bummer. But how many of you can identify if it's parallel or even perpendicular before you start graphing it? Well, if you're looking at the slope, yeah, figure that out, and then your graph should represent that. Okay, so far we had 2 answers. One answer is the lines intersect at one point, and that ordered pair is your answer. Or the lines never intersect, they're parallel, and there are no solutions. Then there's a third scenario. Last problem. Write these 2 equations down, please. Y plus 2x equals 2. Y plus 2x equals 2. And then 3y, make sure I say this right, 3y plus 6x equals 6. Okay, first step is to get them into slope Slope-Intercept Form. So you have the privilege of doing that. Hopefully you're getting better at it. I'll check you in just a moment. Skim Slope-Intercept Form. How many of you got them in slope-intercept form? Okay, good. Now, on your graph paper, bottom left, get that graph. Get those graphs on the same coordinate plane. Go. You can go 4 by 4 in every direction. I'm going to graph it here because I want to see my numbers. All right, time to call in a few new. Sam, can you please show me how to graph the first line? What do I do? Oh. Henry, what's the slope?
Negative.
Nice. Hudson, what's the y-intercept?
2.
Great. Darius, where do I start?
Go down or go up to
1, 2. Great. And then I'll have Philip. Where do I go from there?
Go down to.
Down to? Which way? To the right. All right. What if I wanted to go up? Can I do that, Andrew?
Yes.
How do I do that?
Go up to the left.
All right. And they should hopefully form a line. We'll pretend that's a line. Okay, and then I need help on the second one. Actually, no, I think I can do the second one on my own. Where do I start? Positive 2. Then I go down 2 over 1. Or I can go up 2 over 1. Wait, are these the same thing? Hold on. Was it y, the first problem, is it y plus 2x equals 2? Is that what you have? And the second one is 3y plus 6x equals 6. Is that it? They are the same. You're allowed to say it. Same equation, and therefore they're graphed as the same line. Now, I graph both lines and they're the same thing, right? They're the same thing. Wait, they have the same slope. Doesn't that make them parallel?
No.
What else do you have to be parallel lines? You have the same slope with different y-intercepts. And what do they have? The same y-intercept, so they're the same line. Okay, here's what you have. How many solutions are there for the first line? Infinite. How many solutions are there for the second line? Infinite. You know how many solutions these two lines together have? Yeah, and some of you saw it. Infinitely, and you need to write this down, infinitely many solutions. They're the same line. All their ordered pairs are going to be the same, so they have an infinite number of ordered pairs that are the same, so they have infinitely many solutions. The system does. Can you do that little infinite sign? No. You need to write out infinitely many. And I'll tell you why it's not just infinite, because that is different. Yes, sir.
did number 1 have a name? Like the first problem we did?
No, you just call them intersecting lines. Intersecting lines. And then we had parallel lines, and then we had the same line. So those are your 3 scenarios. Okay, why is it infinitely many? I told you that there are infinitely many solutions on one line and on the other line, but is it any ordered pair will fit? Is it any ordered pair will fit on those lines? Ready? Here's my test. Does this ordered pair fit into both of them? No. Does this one? This one? All of these don't fit, but all of these in here do. So how many are there? Infinitely many, not infinite. That is different. That is not the same thing. That is it. I want to give you one equation because I noticed on your homework, I just want to give you one equation. We're not going to graph it. Just going to show you how to do it if you got it. Look here. Okay, here we go. I'm going to change it just a little bit. This is just to help you out if you get stuck on a homework problem. All right, this is one of the equations from the system. Excuse me, I'm losing my words here. What do you want to do with this equation? Get it into slope-intercept form, which means you want to solve for y. Good. So what do I do here? I'm going to add x to both sides. That's good because you get rid of that negative x, and you're left with 4y equals x, and you can say plus 0, but you don't have to. It's just x. Then what do you do to both sides? Divide everything by 4. And this is where I want you to be careful. You still get y, because these cancel out. But what do you get right here? 1/4 x, because there was a 1 there. So the slope now is 1/4. Up 1/4, which is possible. And what's the y-intercept? Okay, I will remove 2 problems from the person who gives me this answer first. So I'll remove 2 of your homework problems to the individual who gives me this answer first. According to yesterday, this is also a, say it. Say it again. Direct variation. All right, you get the last 2 problems skipped out. It's a direct variation. How do you know it's a direct variation? Is it in the y equals kx form? Tell me yes, no?
Yes.
Yes? Is it y equals kx? And then remember what I said about the y-intercept for the direct variations? Always going to be 0. Okay. All right. Here's your homework.
Why didn't you just let one of us answer? Could have been nice.
Oh. Maybe next time. 2 to the 14 even. And that's on. Oh, I'm going to give you another piece of paper. So hold on. This paper that you just had, that you just graphed a bunch on, you're going to put this somehow in your notes. So you can staple it, you can tape it, you can glue it, you can staple it, glue it, tape it. I don't care what you do, just keep it in there. This is your paper. I'm going to give you another graph piece of paper. So thank you for asking. Page 190.
So we can use, but you're here because of that.
Yes, because you're going to graph. And that's an understatement that you're going to graph. Bye-bye, Swivel.